Hello guys, welcome back to the channel Mathemagix JEE. Welcome guys to this video. In this video, we are going to discuss a problem that is based on the interpretation of permutations and combinations. Okay, this type of problems have previously occurred in JEE mains. So we are going to discuss this problem and this concept that is related to the problem solving approach. We will discuss them in this video. Make sure you attempt this question yourself before seeing the discussion. Okay. So let's start. Here it is saying for non-negative integers s and r, let s c r, this is the binomial coefficient, is defined as s factorial divided by r factorial times s minus r factorial if r less than equal to s. Okay. So this is the usual definition of our binomial coefficient, right? Now it is saying let alpha is equal to 6 to the power 10 minus 6c5 5 to the power 10 plus 6c4 4 to the power 10. So the signs are alternating for individual terms. Okay, and this ends at 6c1, right? This is our alpha and this is our beta. Beta is also defined in terms of some factorial terms, right? Then the value of alpha by beta is asked in this question. Now how to proceed? What will be our approach in such type of problems? Okay, in this problem we are given a series containing binomial coefficients and another series where we are having some factorial terms, right? Now this idea is a bit special because in this approach we have to consider the physical interpretation of this series. Okay, so if I look into this alpha term here, okay, let us decode this alpha first, then we will jump to beta. So let us see what is this term going to tell us, right? So 6 to the power 10 minus 6c5 5 to the power 10. Okay, so let's say 6 to the power 10 is what? We can interpret this thing as the number of ways of distributing. Let's say we have 10 distinct objects. Okay, and we are given 6 distinct boxes. Okay, then 6 to the power 10 is the number of ways of arranging these 10 distinct objects into 6 distinct boxes, right? Now what is the next term saying? It is being subtracted from this previous term, right? And we are seeing here it is 6c5 times 5 to the power 10. That means we are selecting any 5 boxes out of this 6 boxes and then we are filling these boxes with this 10 distinct objects. Okay, now what is the next term? It is, you can see it is of alternating sign, right? Here it was minus sign, here it is plus sign, here it is again minus, here it is plus, here it is minus. So it feels like that we are using the principle of inclusion and exclusion, that is PIE, right? Principle of inclusion and exclusion. So if we try to interpret this series, we are saying that 6 to the power 10 is the total number of ways in which we can arrange these 10 distinct objects into 6 distinct boxes in all possible manner. Okay, it may be something like this, that we put 8 objects here. Okay, 8 objects here and one object here, one object here, right? That is one of the possible cases, and we can take any other possible case, like here if we take 10 objects in this single box, right? So all these cases are covered. Now we are subtracting something from that part, right? So we are subtracting this complete part. That means we are subtracting total number of ways. This is the first term, right? Then we are subtracting this term, that we pick any 5 of the boxes out of these 6 boxes and place 10 objects there, right? In all possible ways. That means this will be, let's say in this case this box will be empty, right? So that means one box empty minus, then we are subtracting this from this, right? So then we have 2 box empty plus 3 box empty, then we have minus 4 box empty. In this case we have 4 box empty, right? Then we are adding 5 box empty, right? Now this part inside this bracket is clearly our principle of inclusion and exclusion, right? So if we combine all of these cases, we will get the total number of ways of arranging these 10 distinct objects into 6 distinct boxes such that at least one of them is empty. Okay, this is the total number of ways we will get by computing this term inside this bracket, right? And then we are subtracting this from the total number of ways of arranging these 10 distinct objects into 6 distinct boxes. That means the final answer we will get, if we try to write alpha, alpha will be total number of ways of arranging so that no box remains empty, right? This is our alpha. Now let us check beta. So as beta is related to this alpha by some constant, that means we can think of beta in terms of this same scenario, because here we are also saying this 10 and 6. That means there may be some relation between this alpha and beta regarding the same scenario. So let us calculate. So if we try to interpret this beta, we have total 1 2 3 4 5 terms right here. Now all of the terms contain this 10 factorial in the numerator, right? So that is interesting, because if we try to interpret this as some group formation, right? Because this thing, the number of ways of arranging this 10 distinct objects into 6 distinct boxes such that no box remains empty, we can also do by group formation. Okay, so beta may be something related to the group formation, as we are seeing here terms like 5 factorial, and then obviously we have something like 1 factorial, 1 factorial, right? We can multiply and divide by this because they are actually 1, so we can multiply and divide by them if we want. That means if we try to divide these 10 distinct objects into 6 groups, right, then we can distribute the groups into 6 distinct boxes, and the total number of ways in that case will also be same as the number of ways of arranging these 10 distinct objects into 6 distinct boxes so that no box remains empty. So if we try to evaluate this beta, let's check first. Okay, let's check by group distribution. So we are basically trying to find 6 positive integers whose sum is equal to 10, right? So let's call this integers x1, x2, x3, x4, x5 and x6. Okay, this is equal to 10, their sum, right? So let us take all the possible combinations here. So we can take, right? So 1 1 1 1 1, right? Then we have 5. This is a possible combination. Then we have here, if we this increase this by 1 unit, so we will get 1 1 1, then 1 2 3, right? 1 1 1 1 3, sorry, this will be 4, and here it will be 3, right? And then what will be the other possible combinations? 1 1 1, then 2, then we can write this 2 here and it will be 3. Okay, then we have 1 1 1, then we have here, let's say, okay, so in this case there are no possible combinations, but let us take this case here. We take 2 here, then 2 here, then we have 2 here, 2 here. Okay, so we have 4 2 and 2 1s. That means their sum is equal to 10, right? And I think there will be no more possible combinations, because other combinations will be just the repetition of any of these 5 combinations. You can check, right? Because the order of them will not matter. We are just finding some 6 numbers whose sum is equal to 10. That's it. This is what we have to do in group distribution, right? So this first combination will give us number of ways equal to 10 factorial, 5 factorial, then 1 factorial whole to the power 5, then divided by 5 factorial, right? Because these 5 groups are alike. Then into 6 factorial, that is the number of group distributions. We are distributing this group to 6 distinct boxes, right? Then for the second case, we have here 10 factorial divided by, this will be 4 factorial, 2 factorial, then we have 1 factorial whole to the power 4, right? Then divided by 4 factorial times 6 factorial. Then we have here 10 factorial divided by 3 factorial, 3 factorial, then 1 factorial whole to the power 4 divided by 4 factorial times 2 factorial, right? Because 4 of these groups are same and 2 of these groups are same, right? Into 6 factorial. Then we have for this case 10 factorial divided by 3 factorial, 2 factorial whole square into, this will be 3 factorial, right? And then in this case we have 10 factorial divided by this 2 factorial whole to the power 4, then we have 4 factorial and 2 factorial. And here I think I missed this 2 factorial because here these two groups are identical, right? And also here will be 6 factorial. So if we count the total number of ways here, the total number of ways, if we try to count, it will be 10 factorial divided by 5 factorial 5 factorial times 6 factorial, right? 10 factorial divided by 5 factorial 5 factorial times 6 factorial. Then we have plus 10 factorial 6 factorial divided by this 4 factorial 2 factorial 4 factorial, that means 4 factorial 4 factorial 2 factorial plus this thing here 10 factorial 6 factorial divided by 3 factorial 3 factorial 4 factorial 2 factorial, that means 10 factorial 6 factorials 3 factorial whole square 4 factorial 2 factorial plus we have here 10 factorial 6 factorial, then 3 factorial whole square 2 factorial whole cube, right? So 10 factorial 6 factorial divided by 3 factorial whole square, then 2 factorial whole cube plus we have here 10 factorial divided by 2 factorial whole to the power 5 times 4 factorial into 6 factorial, right? Because we are also distributing these groups. So then we have 10 factorial 6 factorial divided by, this is 2 factorial whole to the power 5 times 4 factorial. So if we calculate here, the first term is basically the same as this first term of beta, right? This term is same. So if we focus on this second term here, 10 factorial divided by 4 factorial, okay? So it may be this, this or this, right? So let us check the first term here. So 10 factorial 6 factorial divided by 4 factorial. So this part is common. Now let us check this part, right? 6 factorial is basically 720 and this is 24 into 2, right? So 48. That means this will be 30 and here it will be 15, right? So this part here is equal to 15. That means this will be nothing but 15 times 10 factorial divided by 4 factorial, right? So this will be 10 factorial divided by 4 factorial into 15, this term, right? Now let us check this term here. Okay, so we have 10 factorial divided by 3 factorial whole square times 15. So 3 factorial whole square is present here and here. So maybe we can check this term here. So we have here, let's check this term. This term is again 15, right? So 15 times 10 factorial divided by 3 factorial whole square is same as this term. That means this term is also same. 15 times 10 factorial divided by 3 factorial whole square. Then if we check this term here, this will be, if we check this term, right, 2 factorial whole cube 3 factorial whole square, and then in the numerator 10 factorial 6 factorial, right? This term is same. And this term, if we check 10 factorial divided by 2 factorial whole to the power 4 into 15, okay? So this, if we check, so 4 means here will be 2 factorial and this will be equal to 4, right? And then this term again will be equal to 15. So we have 15 times 10 factorial divided by this. That means it will be again 15 times 10 factorial divided by 2 factorial whole to the power 4 times 1, right? So all these terms are matching with the expression given as beta, right? That means beta we can also say beta is also the total number of ways of arranging this 10 distinct objects into 6 distinct boxes such that none of the boxes are empty. Okay, so that no box is empty, right? So we can say alpha should also be equal to beta in this case. That means alpha equal to beta. So from here we can write alpha by beta equal to 1. That means what will be the correct answer for this question? The correct answer in this question will be 1. Right. So this was all about interpreting this two given series to identify that these are nothing but the total number of ways of arranging these 10 distinct objects into 6 distinct boxes so that none of the boxes remain empty. Okay. Now here is a question from JEE Main 2024 where we have to identify these numbers alpha and beta something as the number of ways of creating something. Okay, that's something you have to find. What is that thing? Okay, so solve the question yourself and post the answer in the comments.